Hi guys, so in this series we are going to talk about like we have already talked about double linked list and circular linked list. We will solve some questions. So we have already solved some questions basically. So now this time we are going to solve questions basically this dot. So we are going to say like delete value, value basically. So we'll receive a value and you need to delete it. Okay. So yes, you must be thinking what happens in duplicate. Then you have to like get a calculation how you want to delete that duplicate value. Either of them you want to delete, the first or the last one, how basically. So I mean, yeah, so you can delete a value, the first function. Second is this dot delete at index. So we can say like delete, delete at index, we can say like delete fourth index or something like that, right? So we will receive index. Okay. Then we will implement basically this dot delete. So like these are the basic. This dot, I think we have a reset is like this dot delete linked list. I think we already done it. So these are the basic ones. Okay, we can have this dot get size, like size of linked list. Okay, so these are like this is the basic linked list, and now we will actually we will perform operations on the we will perform like solve more questions. So let's start with first delete value basically. So if you see, we need to delete a value again, right? So again what we have is head. We will start iterating, find a value and delete it. Now it's simple, but it will get tricky. Okay, I will tell you why, how. So you have to think at multiple edge cases. Okay, so now let's say we are talking about this, right? So if you want to delete the third one, so if you want to delete this one, right? So you need to reach the index. If we are like get a value, this value basically we find this value. So we need to reach basically so we need to reach here basically. Okay, so we need to reach here. Okay, sorry, it's really bad. So we can reach here, and then actually you need to delete it, right? So how it's a single linked list we are assuming. So if you see, that's how the single linked list, right? So remember, value deleting is not just deleting the value, it's deleting that node basically. Okay, and if you are if we are this node, if we just change this connection from this to this, and right, we just skip it, so this node will never be reachable, and eventually you can just delete it. So we just need to change this connection. Okay, so now this sounds very simple. Okay, now I will tell you like where this gets tricky. So like 3 or more, it will work great. Okay, now just we have two node only, single node only, right? First you need to check if it's a single node, right? You can just check for the size, what's the size of linked list, or you can just check, right? Like if it's a head only, you can check if it's there or not, you can delete it. If it's the next one, you can directly check it one, you don't want to start the iterator. So for the first two cases you can actually do it. For the third one you can start doing it basically like normal iteration. So but we'll check it. If this head doesn't exist, we don't need to do anything, just return. Now if second condition we check is if this dot head dot value is equal to value, that means simple, right? What we will do is this dot head is equal to null. We can delete now, actually we can delete it also, whatever the references we can delete it, this dot head, and then we can mark it as null also basically. So that will clear it, the like browser will clear it, we don't need to worry, but we can mark it as null, reference gone, that means node is deleted, right? So this is for the, we can also again return. So if we are reaching to the next one, that means the head is not definitely there. So we can check if We can check for the next one also. This dot, like this dot head, you know. So let's start the iterator. Let's do the iteration. So we can have a iterator, this dot head. Okay, now what we will do is this dot while, right? So we will do is while iterator dot iterator, iterator is defined for sure. Iterator dot next is defined, and iterator dot next dot value is equal to value. So because we are checking the value of next, we should know if it's defined first. So actually, yeah, it will actually like, like for the first one only it will, it's not true, so it will break it at first only, so we don't need to worry actually. So yeah, so what we will do is, if that's not the case, we will simply do iterator is equal to iterator dot next. Yeah, keep moving it, and when we will reach it, we know, like basically, like if we just visualize the second case, basically even just like only two nodes exist, so iterator dot next will exist, and iterator dot next dot value, let's say assuming its value equal, so this will become false basically. So like even if we do the whatever we implement, it will still work, right? And for the other ones it will definitely work. So now what we'll do is, what's important here is, I will tell you that iterator, so what we need to do is iterator, right? So iterator dot next, because iterator is at previous, right? So we know iterator is at previous node of the target node, which equal to value. Okay, which like equal to a value, it's actually like just at previous node. So what we can do is, next is iterator dot next dot next. Now if you see, we just remove the middle connection. Whatever the next node is, we remove the next connection, because current node next will refer to the next node dot next. Okay, so keep the next node. Yeah, it's done, and yeah, our one is deleted, so we can actually just return it. Yeah, so yeah, this should work. So let's try it. So okay, so what we need to do is, we are printing, let's try this first. Yeah, so it's working. We have 0 to 9. Now we have L object dot so what's the function delete value, right? So delete value, let's say we want to delete. Okay, I think we haven't, so okay, so yeah, sorry, actually that's the wrong thing. If head is equal, if head doesn't exist, we will go to that, but if head is equal already value, so we don't set head to null, like we are removing that. So we will do it this dot head dot next. So because we know head exists, so either it's null or something, so head will automatically becomes null, but otherwise it will set to next basically. Yeah, so that's actually the one mistake. So yeah, so now we are deleting, we'll start with deleting head basically, so 0. Okay, and now we should print the linked list. Yeah, so it's printing 1, correct. How about if we do it again? Now this time we know head is 1, so how about if we again delete 0, something which doesn't exist? Yeah, something wrong. Now this time something wrong is happened, that delete a value, this exists, iterator dot next. What if it actually keep reaching, doesn't find, if iterator doesn't exist, right? So if iterator doesn't exist, we will simply return basically. that means like let's say we have 3 nodes, right? So we are at head dot next. Okay, it doesn't value to go to second. Again third exists, it will go to again basically. Okay, again say from second to it goes to third. Now no, if we'll check third doesn't, if we see if we see like third dot next is null actually, so it will become false. So if iterator because that means it's already at last node, right? Last node. So even last node if equals, it should be the previous one. So if iterator dot next doesn't exist, so we should return it basically. Okay, so 68. So okay, 68. Yeah, actually it should be this one. Yeah. So now it's working, right? So again we got the correct output. How about if we delete 1 again? So if you see, we are getting 2 correctly. So let's delete 5. So if you see, the C5 is skipped. So let's do 9. Yes, correct. About last second. So that's how you will try to do multiple cases basically to make sure that it's working basically. So yeah, so as you can see, this is working perfectly. Basically now this code is like very similar basically. The next one, deleted index, is kind of similar. So let's format it. So okay, so actually okay, so we know like if head doesn't exist, we'll delete it. If so we will change it to index is equal to 0, so we'll just change it to head to next. That means, right, so else what we'll do is iterator, and we will have I is equal to 0, right? So what we will do is I delete it because I think we haven't defined size. So iterator is defined, so iterator is equal to iterate next and I plus plus, and I not equal to the index. So if it is, let's say 1, so it will come at 1. So basically, so now we will so this so then again, like if index is like, even if it's the last index, we need to delete. So iterator is defined and last index iterator, the iterator is not defined. Let's say like iterator index is out of the bound 15, so it next will become eventually undefined basically. Yeah, otherwise we will check it here. We can just put a check if I is equal to index basically, then we can do like iterator. Now we are like index, right? So okay, so similarly I think it will be very similar, iterator dot next actually. So yeah, so it will be iterator dot next, and yeah, so if I is equal to index, you can do the same and it will work. Yeah, yeah. So if we do at index at 0, so that means it should keep working something similar. So if you see the second one, we deleted index 0, it was start from 1 now. In second we deleted index 8. So again so we deleted index 8, that means okay, so okay, because we have already deleted, so it becomes 8 index. So right, so let's do this. So yeah, so 0 is deleted. So what if the linked list is printed 1 2 3 4 5 6 7 8 9? So that means 0 1, so 9, that means, so this one is 8, so 9 should be removed, right? So that means, so that is like 8 index. So we want to remove the last one, so last is not removed. Okay, that's interesting. So last is right. So when we iterate last node, so iterator dot next is a null, so if this becomes false, but at this equal, actually this is also becomes, so iterator dot next, so return ho gaya. Oh okay, we don't do that. So we can check it now that I is equal to no, so we can now check. So you know, so if it is at just like, let's say if it is at 8, basically in our case it is at 8, so we know that 8 dot next, right? Yeah, so now you see, like here we just need to see what's the problem we are stuck in, right? So we can put iterator dot next, else we can put it as null, right? So yeah, again it's not removed. Okay, that's surprising. Okay, so now the question is like, why it's not removed? Okay, but can we check if this, if I do 7, then I think 8 will be removed. Oh, so, okay, so nothing is actually, nothing is being removed actually. Okay, so actually, okay, so what we can do is that actually, because we want to do it, so I plus 1 actually, how about if we just, because we are like using index here, so what if we just stay at a previous index? So index deleted is 0, we already deleted it. What if not? Then we just wait for it, like, so if it is the last index controller, we wait for the previous one and we will wait there. So if we know 0 plus 1 equal to 1, if it is equal, like not equal, this false, so then we will actually, so we don't need to, you know, so basically if I plus 1 equal to index, then we can actually do this. Okay, which index we delete? Try to delete now 5. Okay, so it's at 4. Okay, so yeah, so if you see now 6 is being deleted. Yes, now it's working correctly. Now if you use 6, now if I think if we use 7, you see now 8 is being removed. If we use 8, now 9 should be removed. Yes, correctly, now it's working perfect. If you 9, it's out of the bound, so here nothing should happen. Now it's working perfectly, right? So you just go step by step, debug it, just check the logic again, and that's how we will do it. Linked list is very simple. This dot reset, we have it again, and yeah, so here we will simply return this dot size. I mean, like, I'm not sure, so actually this is slightly weird, it's not expanding it, but yeah, so these are the basic operations of linked list. I mean, we have done it, and yeah, so thank you so much for watching, And now in the next one we will try to solve 5 to 6 questions of linked list, which are like most famous questions, like to understand the concept of linked list and also from interviews perspective. So stay tuned. Thank you.